Even stepping into an elevator can kill your signal. Drive down to an underground parking garage, and your call drops instantly. Our wireless connections are fragile. The slightest obstruction, and they're gone. Yet right now, at this very moment, something impossibly far away is still talking to us. How far? So far that even light, the fastest thing in the universe, takes a full day just to reach it. The one doing the talking is Voyager 1, a spacecraft humanity launched into the cosmos 50 years ago. This machine is still sending greetings home to Earth, and its voice? Weaker than the tiny bulb that flickers on when you open your refrigerator door. But here's where the story gets truly mind-blowing. That voice is about to go silent forever, and the moment it does, this machine will somehow become immortal. Even as you watch this, that spacecraft is hurtling away from Earth at 17 kilometers every single second, faster than any bullet ever fired. And yet, it's so unimaginably distant that it appears completely frozen in place. The gap between us right now? A staggering 25.8 billion kilometers. If you sent a message this morning, it wouldn't arrive until tomorrow. The signal coming from that distance is almost nothing. The transmitter puts out just 22 watts of power, barely enough to light that one refrigerator bulb. And it's screaming that into the entire universe. By the time that faint whisper travels a full day and reaches Earth, its strength has shrunk to less than 1/4,000,000th of what it started as. Imagine the delicate pressure of a single snowflake drifting onto the back of your hand. The signal arriving at Earth is even weaker than that. So how is this possible? Our phone signal dies in an elevator. Yet this whisper, launched from beyond the edge of the solar system, reaches our ears clearly. What's the secret? It's split between both ends. On Voyager's side, a car-sized dish antenna doesn't scatter the signal in all directions. It focuses everything into one razor-thin beam aimed precisely at Earth. Like using a magnifying glass to concentrate sunlight into a single burning point, it channels every last drop of power toward one tiny target. Now, Earth's turn. Humanity built enormous ears across the planet. Dishes the size of half a football field stand in the American desert, the Spanish countryside, and the Australian outback, one on each continent. Why spread them so far apart? Because Earth never stops spinning. If you only had one dish, the planet would eventually rotate it away from Voyager. So as one ear dips below the horizon, another rises to take over. They pass the signal like a relay baton, so no matter how Earth turns, not a single whisper is ever missed. But there's still one more wall to climb. Voyager's signal isn't the only thing pouring in from space. Cosmic noise floods in from every direction, threatening to bury that fragile, real voice completely. So the receivers attached to these giant ears are chilled to temperatures colder than the coldest known place in the universe, cold enough to silence even the microscopic vibrations of the machine itself. Every possible source of interference, frozen out. And there's one final adjustment. Because Voyager is racing away so fast, its signal arrives slightly stretched and lowered in pitch, just like a speeding ambulance siren that drops in tone as it passes you. The receiving equipment continuously corrects for this shift in real time, retuning with every passing moment. A car-sized dish focusing the beam. 3 half-stadium ears taking turns. Receivers frozen beyond cosmic cold. Constant pitch correction. All of that just to catch one faint word. And this machine has died and come back to life. More than once. The way it was saved each time makes almost no sense. Here's what you need to understand first. For Voyager to send anything home, its antenna must be pointed at Earth with absolute precision. Even the slightest drift, and that whisper vanishes into empty space forever. Remarkably, this machine knows which way to face by reading the stars. Just like ancient sailors who aligned their bows to the North Star, Voyager uses a fixed set of reference stars as its compass. It measures its own drift, then fires tiny thrusters to correct its posture. Alone, in the dark, billions of kilometers from anyone. It has been doing this for decades. Like holding a flashlight perfectly aimed at a single window across an ocean, without ever putting it down. But thrusters are mechanical parts, and mechanical parts wear out. After decades of non-stop firing, they began to fail in 2017. If nothing changed, Voyager's voice would drift off into the void forever. That's when engineers made a desperate gamble. Hidden on the opposite side of the spacecraft were backup thrusters that hadn't been fired since Voyager passed Saturn. 37 years of complete dormancy. Enough time for a newborn baby to grow up, raise children, and go grey. Nobody could guarantee that engines frozen for that long would ever fire again. One wrong move and the last backup was gone too. They pushed the button anyway. Then they waited a full day for the answer. At that distance, saying, "Are you okay?" means waiting 2 days for a reply. At the end of that agonizing wait, those long sleeping engines woke up, as if they'd never stopped. Bought Voyager several more years of life. But the next crisis was even worse. One winter, the steady, coherent signal from Voyager suddenly turned into endless, meaningless gibberish, like a person who had lost the ability to speak. It took months just to find the cause. A single corrupted memory chip, one damaged cell in a vast storage bank, like one dead slot in a laptop's RAM, causing the whole system to babble nonsense. There was no repair crew to send, no replacement part to ship. The only option was to give instructions across an impossible distance using nothing but words. Engineers pulled out 50-year-old blueprints and painstakingly relocated the corrupted commands, splitting them up and redistributing them into other healthy memory spaces. It was like playing Tetris inside a machine you can never touch, by remote control, across billions of kilometers. One command sent, one day to arrive, one day for confirmation to return. That slow, grinding conversation continued for months. Then, in the spring of 2024, the signal came back. Coherent, clear, human again. No repair in human history has ever been performed at a greater distance. Looking back, this traveler has fallen and risen so many times. When one engine gave out, it woke another. When memory failed, it squeezed meaning from what remained. Resilient isn't a strong enough word. This is something closer to pure, relentless will to survive. Just how extraordinary that will is becomes clear when you look at the other probes that left around the same time, heading into the same darkness. They went silent long ago. Every last one of them. In this vast and endless darkness, only 2 machines still send their greetings back to Earth. Voyager 1 and its twin. Like a lone soul awake while the whole world sleeps, waving a lantern toward a home it can no longer see. But even this relentless determination has one unstoppable enemy. Time itself. Because the heart of this machine is slowly, quietly going cold. Voyager carries no solar panels. Out where it drifts, sunlight is so faint that trying to charge from it would be like heating a football stadium with a single candle. And filling it with fuel was never an option either. So humanity gave it something extraordinary. A strange and remarkable heart. A chunk of material called plutonium. A substance that generates its own heat simply by existing, keeping this machine alive for nearly 50 years without a single gas station or ray of sunlight. But this heart came with a fate written into it from the very beginning. The time it takes for its heat to drop to exactly half is fixed at roughly 88 years. Like a silent, unmarked clock sealed inside, ticking without a sound, draining the traveler's strength with every invisible turn. At launch, this heart produced around 470 watts, enough to light a few bright incandescent bulbs. Today, it has fallen to barely 230. Nothing is broken. Nothing has failed. It simply loses about 4 watts every single year. Like a flashlight growing dimmer today than yesterday, dimmer tomorrow than today. Honest, inevitable, unstoppable. And there are no hands anywhere in that impossible distance to swap in a fresh battery. So for years now, the people on Earth have been making quiet, painful decisions. With the remaining power unable to run everything, they switch things off, one by one. Imagine a family in the dead of winter, struggling to afford the heating bill. They darken the unused rooms first, lower the thermostat in the living room, and eventually everyone huddles together under blankets in the smallest room left. That is exactly where Voyager is right now. The cameras that once captured the cosmos have closed their eyes. The heaters that kept its body warm have been switched off one by one. Even knowing that components freezing in temperatures hundreds of degrees below zero could mean instant death. The instruments that once measured the universe are falling asleep in sequence, stretching one day's power into two into 3, pushing the farewell back just a little further, just a little longer. We usually think machines stop because something breaks. A component fails, something shatters. But this traveler is different. Nothing needs to break. No accident needs to happen. When the appointed moment arrives, it will simply and quietly run out of strength, a heart growing old and cold. That is its first and only malfunction. That day is expected to come sometime in the 2030s, but no one will know exactly when, because this traveler's farewell comes without a final goodbye. One day, a signal will arrive as it always does, and the people waiting will do what they always do. Wait for the next one. But the next day, nothing comes. And the day after that, nothing either. Only then will they understand. That perfectly ordinary signal from a few days before, that was the last one. It sounds like the end of the story. doesn't it? For most machines, it would be. But this one is different, because the truth is, everything that really matters begins after the voice goes silent. Even when the power dies, this machine does not stop. On the very night that last signal fades, Voyager continues moving, quietly, steadily forward. Losing power doesn't mean standing still. It's natural to wonder, if it keeps flying forever, won't it eventually reach some distant star? But this traveler has no destination. It was never given one. Have you ever slid a stone across a frozen river in the depths of winter? Even the slightest friction on the ice and it slows, then stops. But the space between stars is incomparably smoother than any ice. No air to resist it, nothing to drag at its momentum. A stone pushed once on that kind of surface slides, and slides, and slides, forever. That stone is Voyager. But surely, in a universe this vast, it must brush past something eventually? It does. In the direction of the constellation Camelopardalis, there is a small red star called Gliese 445. By all calculations, in roughly 40,000 years, Voyager will reach its closest point to that star, just 1.6 light-years away. A distance that even light itself needs a full year and a half to cross. But here is the twist. We imagine Voyager walking steadily toward that red star, but in reality, the star is racing toward us. Think of walking alongside a moving walkway at an airport. No matter how fast your own legs carry you, the person riding the belt glides past you effortlessly. That red star is approaching 7 times faster than Voyager is moving, striding out to meet it. And yet even at their closest, the distance between them remains staggering. The star sweeps past like a stranger brushing shoulders on a crowded street. No embrace, no greeting, and drifts away again into the dark. Perhaps in this universe, even the closest encounters are nothing more than a passing brush. So is Voyager truly alone, untethered, drifting with nothing to hold it? Not exactly. The entire solar system, everything we call home, is itself sweeping in a vast orbit around the center of the galaxy. Like a passenger sitting on the outer edge of a carousel, perfectly still in their seat, yet carried in a great slow circle by the ride itself. Voyager is that passenger. It may have turned its back on the sun, but it still rides the same carousel. Now an artificial planet circling the galaxy alongside everything else. Now let's climb the staircase of time, one enormous step at a time. People often say Voyager has already left the solar system, but the true boundary is still far ahead. In roughly 30,000 years, it will finally cross the Oort cloud, a vast, spherical shell of icy debris that wraps around the sun like a final frontier. The journey we thought had already ended will only then be taking its very first real step. Push further, 1 million years from now. The Big Dipper, Orion's belt, the familiar shapes we trace in the winter sky, will no longer look the same. Like paper boats set side by side on a river, slowly pulled apart by the current, the stars drift in different directions at different speeds, and the constellations we know will dissolve into unrecognizable patterns. Beneath that altered sky, Voyager will still be gliding silently through the dark. And now the final step. Less a calculation, more an act of imagination grounded in physics. 10 trillion years from now, it's almost impossible to feel how far away that truly is. Take the entire age of the universe from its very beginning to this moment and live it again from start to finish, 700 times over. That is the kind of time we are speaking of. By then, the stars of the universe will be going out, one by one, like candles extinguished at the end of a long, long night. In that vast, darkened universe, this tiny machine, no bigger than your hand, may still be drifting alone, endlessly turning through the void. Do you remember? At the very beginning of this story, we said that Voyager becomes eternal precisely at the moment it goes silent. And here's why. While its voice was still alive, it was just a worn-out machine. Fragile, uncertain, always on the edge of going quiet. But the instant that whisper finally stops, there is nothing left to lose. No heart to grow cold, no parts left to fail. Because it is gone, nothing in the universe can end its journey. And yet, through all that impossible voyage, Voyager does not travel empty-handed. It carries exactly one thing, a golden disc, roughly the size of 2 open palms placed side by side. A copper record coated in gold, about 30 centimeters across. Humanity pressed everything Earth has ever been into that single, thin disc, like a letter sealed in a bottle and thrown into the ocean. Except no one knows the address. The ocean has no shore, and the bottle is made of gold. First came voices, greetings in 55 languages, and among them, Korean. Annyeong gaiseo, That one word you say every single day without a second thought is, right now, passing between the stars. Who chose that voice, and why that particular accent? Only faded records remain. But one thing is certain. The Korean word that has traveled farthest from Earth is simply hello. Music was included too. From Bach echoing through cathedral ceilings to Chuck Berry blazing down the highway on a guitar. Some pieces move as slowly as a funeral. Others burn as bright as a midnight celebration. Humanity chose not to explain what it listens to when it grieves or when it rejoices. It simply played the songs and let them speak. Beyond music, the sounds of Earth itself were recorded. Thunder rolling in, waves crashing ashore, birds calling out, a newborn baby crying its very first breath, the laughter of people passing by. And at the end, a heartbeat. Because even if no language translates, a heartbeat might be understood anywhere in the universe. The photographs chosen are surprisingly ordinary. No spacecraft, no monuments, no great figures of history. Just a person haggling at a market, a family gathered around a dinner table, a mother nursing her child. Perhaps humanity already understood. What makes us human is not the grand events, but these quiet, unremarkable evenings. One of the people who helped create this message was a woman named Anne Druyan. She spent an hour recording the electrical waves flowing through her own brain and pressed them onto the disc. Eyes closed. What was she thinking about? Love. Just days earlier, she had confessed her feelings to a man, and the trembling of that moment had not yet faded. It was only 2 days after that confession. So traveling through the darkness right now, on that golden disc, is the heartbeat and the thoughts of someone who had just fallen in love. People come and go, but the feeling of that single day still drifts between the stars. The person who brought all of this together was Carl Sagan and his colleagues. They knew from the very beginning that whoever received this message would not recognize a single letter or number from Earth. So on the surface of the disc, they engraved, using only images, instructions for how to play it, a wordless guide for a stranger, communicating entirely through gesture and symbol. Beside it, they etched a kind of clock. No hands, no numbers. Just a small amount of a substance that decays with perfect honesty, halving itself over and over. It takes 4.5 billion years to reduce by half. Whoever finds this disk one day can measure what remains and calculate exactly how long it has been wandering. The disk itself was built to last approximately 1 billion years. A span of time that dwarfs the entire history of humanity, repeated over and over again. And here is where something strange becomes clear. Our tallest buildings will crumble. Our fastest machines will be forgotten. But the longest lasting trace of humanity in the universe turns out to be a greeting pressed into gold, a handful of songs, and the heartbeat of someone freshly in love. Not a monument, not a declaration of power, just a hand extended toward an unknown face, saying, "We were here, and we were doing just fine." In the winter of 1990, Voyager had nearly completed its long mission. But before it moved on, it turned its camera one last time, back toward where it came from. From 6 billion kilometers away, Earth appeared as nothing more than a single point of light, less than 1 pixel on the screen. A pale blue dot, impossibly small, lost in the dark. And on that dot, every single one of us, without exception, is riding. A machine that reached outward to say hello to a stranger it will never meet, and looked inward to reduce everything we are to a single point of light. This aging traveler, slowly losing its voice, has become eternal. So perhaps there is no need to worry about what happens to galaxies 10 trillion years from now. Because what this quiet machine drifting through the dark is really telling us is that what matters is here, and now, and today. If you could leave just one message for the universe, what would you say?